Okay, so continuous distributions. How are we going to work out the expected value? Because we can't write up that distribution table anymore. So what do? So x is going to be our continuous random variable. Well, it all comes down to integration again. We integrate xfx. Remember, fx is what we call a probability distribution function. But just like we saw with discrete, in our table we went xpx. So effectively we're doing the same thing. We're going to integrate xfx. And it still turns out that expected value is the average. And here is our proposed model. Quarterly salary, X is measured in thousands of dollars. And here's how they're working out the pay. Interesting. 2,560 x to the power of minus 7 on 2, where x is greater than or equal to 16. We're going to look at the median and the mean to describe the distribution of those salaries, how this company works. So let's do the median first. The first point was 16. So we're going from 16 to the median. We want that integral to be a half. So add 1 to the power over the power. And when we solve that, we get 21.112. But remember, this is measured in thousands of dollars. So the median quarterly salary, $21,112. Now, work out the average. Still integration, but we've got x times x to the minus 7 on 2. You notice I've put infinity there. We do that sometimes. I mean, technically, I suppose we should be saying the limit as n approaches infinity for there, but it's fine for something like this. Integrate that, add 1 to the power over the power, but of course now I've got to use the limits, so at some point I've got to acknowledge I'm using limits, I guess. So I'm saying, well, I know the limit as x approaches infinity of x to the power of minus 3 on 2 is 0. Therefore, I'm left with minus 5,120 on 3 times minus 1 on 64, and we get that the average salary is 26,667. Describe the distribution of the salaries. Here's a term you might not have heard for a while. Oh, well, it's positively skewed. Positively skewed. Okay. So when your median is less than the mean, that means more than 50% of your data is on the left-hand side of the average. So that's what we call positive skew. Now, if the median is greater than the mean, then more than 50% is on the right-hand side, and that would be negatively skewed. Variance. So how do we do the variance then? Well, same deal. Remember, we used to do it this way, and we still do. It doesn't matter whether it's discrete or continuous. The difference is how we actually find these things. So mu, or the mean, what we just did, how do we work out the variance? Again, it's exactly the same idea as discrete, where, remember in our table, we would have then had a column x squared times the probability. So now we'll integrate x squared times the probability density function. So let's find the standard deviation of our salaries. It'll end up being, well, this. I've combined it all into one thing. So expected value of x squared will be the integral from 16 to infinity, but then minus the mean that we just worked out. I've converted it to a fraction. It actually turns out to be 80 on 3 if you work it out. So it's 80 on 3 squared. So let's calculate this. Integrate x to the minus 3 on 2. Add 1 to the power over the power. Again, that limit would be 0. And we end up with, wow, quite a large amount. But of course, we want deviation. So you see something like that, 568, you think, wow, what a large spread. But remember, it's deviation that we want. So we find the square root of that, and we get something a little bit smaller, 23.851. So there's the deviation. Yeah. What is deviation measuring? It's basically measuring the average distance away from the mean. So the data will get more clustered about the mean, the smaller the deviation. So that means it's closer and closer to the mean. And in fact, that would be our graph. And so you see, there's the median, there's the mean. You see how all the data has been pushed to the left-hand side, making it positively skewed. And that's probably typical of a company's salaries when you think about it. A lot of people in the company are getting lower wages, and then the lucky few are getting the very high wages. And that tends to be what happens in society generally. So, 16C.